Hi, I have a lesson here that's going to help us calculate square roots and also look at perfect squares and how to calculate their square roots. So before we get into it, we should just take a look at a square root. What is it? So I have the definition here of a square root. It's one of two equal factors of a number. Now, for me personally, I like to think of square roots as what number multiplied by itself is equal to that number underneath the radical. Now, some of you are asking, well, what's a radical? That's what's going to come under my facts here. I put a fact about a square root is the opposite of squaring a number. So we've talked about squaring things. Well, now this is going back the other direction. And that radical that I was talking about is that it kind of looks like a division sign, but it's got that little extra piece on it, and that's the radical symbol, which is telling us in almost all cases to take the square root. Sometimes there'll be another little number in it, and then it's not the square root, something totally different that we don't have to worry about. But right now, that radical to us is going to tell us to take the square root. Now, I have some examples here. I just said, well, the square root of 25. It's 5. Why is it 5? Because 5 times 5 is 25. Now, I have another one that I have a typo on. This should be a 25 right here. Please put that in your notes that way. That says the negative square root of 25. And again, I have this all messed up. This should also be a 5 here. So the negative square root of 25 is negative 5. And this is how I look at it. I go, if I were to just look at that much of it, let's ignore the negative. The square root of 25 is 5. But since it had the negative in front, our answer also has to have that negative. That's why the negative square root of 25 is negative 5. Now, sometimes we're going to put a plus or minus in front of that square root symbol, and then that just means we have to put a plus or minus in front of our answer. So it's just saying that 7 could be an answer or negative 7. Now, we get into the square root of a negative number. This one is, it's not a real number. And the reason for that is because if I look for a number that multiplied by itself equals negative 16, I can't find it in the real numbers. You know, I would look at the number 4. 4 times 4 is 16, not negative 16. If I went to, well, maybe it's negative 4. Well, negative 4 times negative 4 is still positive 16, so that doesn't work either. So if you see the square root of a negative number, it's not a real number. And you'll get to discovering those kind of problems in a later math class. Just some non-examples. I put a little bit of what I was talking about earlier when we looked at the radical sign. It kind of looks like a division sign, and sometimes people think it means to divide by 2. It does not mean that. Does not mean. So put that in your head right now that the radical does not mean divide. It means it's asking you what times itself equals that number underneath. Now, the next piece of vocab I have here is what's referred to as a perfect square, or perfect squares. And it's a rational number whose square root is a whole number. We can take square roots of lots of numbers, and sometimes they come out to be decimals, and sometimes they come out to be whole numbers. So here I have a big list. Is it the entire list? Absolutely not. But this is a big list of perfect squares. Now, I'm going to show you on the next page why these are perfect squares. So I took all those numbers from the previous page, I turned them purple, and I put a square root over the top of them. This is why they're perfect squares. Because if I take the square root of 1, I get 1. If I take the square root of 4, I get 2. Square root of 9, oops. Square root of 9 is 3, and the square root of 16 is 4, so on and so forth. So when I take the square root of all of these numbers, notice my answer is a whole number. And I continue on with this side. Square root of 21 is 11, square root of 169 is 13. And like I said, this just keeps going and going and going and going. And you see them all. I have these. The square root of 441. Anybody got it? 21, right. How about we get down here to the square root of 625? Some of you are seeing the pattern, 25. But how about the square root of 900? It's not 26. I skipped some in here. So now I look at this square root of 1600, that's 40, and like I said, I have a lot of them here. And the reason that these are all perfect squares is because the answer to the square root of it is a whole number. Now I have a few examples here. I want to calculate the square root of each one of these. And when I look at these, I look at all of them and I ask myself, what times itself, in this case, is 81? Well, the answer is 9. Now, some of you are going, but negative 9 would also work. You are correct. However, when we're calculating the square root, it's really asking us for what's referred to as the principal root, something I'm not real concerned about, but the principal root is the positive answer. So when it asks for the square root of 81, we only give the positive solution, which is 9. Now, we come over here to 256. You're like, I can't remember what times itself is 256. Well, come back here. This is very handy. Maybe it's a perfect square, and if it is a perfect square, it's going to probably be on this list. So I look here and I find, 256. That's, well, you can't see where I'm pointing, right here. Well, so then the answer is 16. So I come back here and go, well, it's 16. How about the square root of a fraction, though? That one's not on this list. So how do I do that? Well, when you take the square root of a fraction, it's just like taking the square root of the numerator and the square root of the denominator. So now you look at it and go, square root of 4, that's 2. And the square root of 9, well, that's 3. So the square root of 4/9 is 2/3. Now here's why. If you take 2/3 and you multiply it by 2/3, 2 times 2 is 4, 3 times 3 is 9, and there you go. What times itself is 4/9? It's 2/3. That's why it's your answer. Now we have the negative square root of 16 over 64. I know my answer has to be negative because there's this negative out in front. And then I just look at it like I did in the previous one. What's the square root of 16? Square root of 16 is 4. Square root of 64 is 8. Now I look at that though and I go, I can simplify that fraction. That fraction is going to simplify to negative 1/2. And there is my answer. Now this one has another way to do it. You could have looked at this from the get-go. It's negative square root. Now let's simplify the 16 over 64 underneath the radical. Both of those are divisible by 16. So the 16 becomes 1, the 64 becomes 4. And the square root of 1/4, well, again, I'm going to do it the same way. The negative's still there. Now, what's the square root of 1? That's 1. What's the square root of 4? That's 2. And notice, either way we do it, we get the same answer. So you can simplify what's underneath the radical first, or take the square root and then simplify. Now I have these. Well, the square root of 225, that's 15, because 15 times 15 is 225. Now you look here and you go, well, square root of 2.25. That wasn't on my list of perfect squares. But here's the thing I want you to look at. If we ignore the decimal, it says 225 again. So we have a form of 225. So we would think our answer would be 15, but it's not 15, because that's obviously way too big. But if I go 1.5, does that work? Yeah, now if I take 1.5 and multiply by 1.5, you get 2.25. Therefore, the square root of 2.25 is 1.5. So you come over here and I have the next one, number 7, the square root of 22.5. You'd go, well, that's 225, square root of that is 15, so it must be a form of this. Just move the decimal over, move the decimal to here. Well, that doesn't work because that was the square root of 2.25. You can't leave the decimal here because that's 15, and if we put it there, 0.15 gets even smaller. So for this one, can we take the square root of it? Absolutely, but we don't know how to do it yet. So I'm just going to write not yet for this one. Because we can take the square root of it, we're just not there yet. Then I have my next one, I have, well, the square root of 4. What times what is 4? It's 2. Now I have the square root of 40,000. Well, I see that 4 in front and there's just a bunch of zeros after it, so I go, well, maybe it's some form of 2, and just put some zeros on it. You're right. Now in this case, 200, because I have to take 200 times 200 to get to 40,000, and the square root of 40,000 is 200. Now we have the square root of 40. Well, you see the 4 there, and then that extra 0, I'd go, well, must be a form of 2. Just put a 0 on it, and the square root of 40 must be 20. But hold on. 20, oops, 20 times 20 equals 400, not 40. Well, then you think move the decimal over to right here. Well, that's the same thing as the square root of 4, so that doesn't work. So again, we have another one of these where, can we take the square root of 40? Absolutely. Do we know how to do it? Not yet. We're going to get there, just not in this lesson. How about this square root of negative 25? You look at it and go, well, 5. But 5 times 5 is a positive 25. You go, wow, then it must be a negative 5. No, because if I go negative 5 times negative 5, that's positive 25 again, so that doesn't work. So if you remember back, I had one of these in my non-examples. Square root of a negative is, this is not a real number. Can you take the square root of it? Yes. Kind of one of those not yet things as well. Then I have another one over here. Now it's a fraction, but I also notice it's the square root of a negative fraction. So this one is also not a real number. Someday we're going to learn about that, just not today. Oh, and these are repeats, so we don't need to do those again. Ignore those. And here, now we're going to look at solving an equation. So here we want to, in number 13, we want to get the a all by itself. So if you think back to that, one of the very first slides where we had a fact, the square root was kind of the opposite of squaring. So if we have something that's squared in this a squared, we want to undo that, so we have to take the opposite of it, which is the square root. What's the square root of a squared? It's a. Well, if we take the square root on the left side, that means we have to do the same thing on the right side, just like any other equation that we work with. And the square root of 81 is 9. Now, in an equation, this is where it's a little different. Kind of goes against what I said earlier. When you take the square root in the equation, not only do we have to look at the positive answer, but we also have to look at the negative answer. So we like to write it like this, as a could be 9 or negative 9. If you rather, you could write them both out. A could be 9, and a could be negative 9. So whether you want to write your solution like this or like this, it does not matter. Now I'll come over here to my next one. Y squared equals 10,000. So square root of both sides, y equals, well, the square root of 10,000 is 100. You could check that. 100 times 100, yeah, that equals 10,000. Now don't forget, it could be positive, but it could also be negative. There's our solution. Now if you wanted to rewrite it as the two little solutions, y equals 100 and y equals negative 100, you may. M squared equals 0.16. Square root of both sides. I noticed that there's 16 in that, so that would tell me that it must be some form of 4. Well, 0.4. What's 0.4 times 0.4? 0.4 times 0.4. Well, 4 times 4 is 16. Then I have to move the decimal over 2 places. 0.16. Perfect. I got it. So m, square root of m squared is m, equals, and then don't forget we have our plus or minus. Sometimes it's nice to have that 0 in front of there just so we can see the decimal. And there's my solution to that equation. And then last but not least here I have f squared equals 121 over 144. Well, again, I want to get the f all by itself, so I take the square root, and then I have to take the square root of the other side. So here I get f. Now remember, when you take the square root of a fraction, just take the square root of the numerator. Well, the square root of 121 is 11, and then take the square root of the denominator. The square root of 144 is 12, and since we're working in an equation, we're going to have both the positive answer and the negative answer. So we have two solutions there, positive 11/12 and negative 11/12. And that's going to conclude my lesson on square roots.